Today we are going to see different types of loads. There are three types of load. First one is direct load. There are two types of direct load. First one is tensile and second one is compressive. Let's see direct load. Consider a body and this is CG of the body and axis, that is line passing through the CG, and force is acting on the axis. This is axis of the body. Types of direct load. First one is tensile. Consider a body and this is axis of the body. Two forces acting on either side of the body which are pull in nature. This is a body and when two forces are acting on the body, what will happen? Body will get elongate. L is original length of the body and this is L2 is final length, and delta L will be elongation, that is change in length due to application of tensile force. So delta L is equal to change in length of the body, that is equal to L2 minus L1. Next, compressive load. Consider a body. This is axis of the body and load is applied along the axis. These are the two forces applied on either side which are push in nature. What will happen if compressive load is applied? This is original length of the body, that is L1. When compressive load is applied, body will get contract. This is final length, that is L2, and delta L is contraction, that is change in length, equal to L2 minus L1. So tensile is pull type of load and compressive is push type of load. Another type of load is tangential, that is shear load. Let's see. Shear load. This is a body and force applied tangentially to the body. This is line of action of the force and this is axis of the body. So line of action and axis are do not coinciding each other. This is tangential forces. This is tangential forces. What will happen if forces are applied? The shape of the body will change like this. This is called as shearing. Consider a body made up of infinite number of layers. Look into this diagram, and tangential forces are applied on the body. What will happen? Upper layers are trying to move forward and lower layers will try to move backwards. This is called as shearing. For simplicity, take only two layers. These are forces. What will happen? Upper layer will move forward. So this is a shearing plane, the plane along which body shears. Third type of the load is eccentric load. This is 3D model of the body, three-dimensional view. This is necessary for visualization, easy visualization. This is force, that is direct load acting along the axis of the body. This is tangential force acting along the tangential to the surface. This is axis. And this is tangential direction to the surface. When force is applied between direct or tangential load is called as eccentric load, and the distance between axis and line of action of eccentric load is known as eccentricity. Eccentric load is applied between direct and tangential load, that is neither along the axis of the body nor along the tangential direction. So eccentricity is distance between or distance from axis at which load is acting, or distance between axis and line of action of eccentric load. Let's see in the diagram. This is axis, this is eccentric load, and this is the line of action of load. So distance between these two lines is called as eccentricity. which is denoted by small e. So, in short, types of loads. There are three types of loads: direct load, eccentric load, and tangential load. And direct load again classified as tensile and compressive load. So next, types of stress. First of all, we must know about stress and pressure. So what is the difference between stress and pressure? First of all, we are going to see pressure. Let us take an example. If you are applying force by hand on the door, so this is the area of your hand and P is the force applied by you, by your hand. So pressure will be external force, that is force applied by you, and area, that is area of your hand, that is you are applying pressure on the door. So P is equal to force by your hand and per unit area of your hand. Similarly, this is a pen and this is pointed nose. You are applying force by pointed nose on the area which is very smaller. If we apply force by backside of the pen, then area will be larger. So this is force and area. Here pressure is equal to external force applied by pen per unit area. So what is stress? Consider a body and it is made up of atoms or molecules. These are atoms and this is intermolecular space. When we apply force, that is external forces on the body, what will happen? Body will get compressed. That's why body will try to attain original shape. So body gives internal reaction that is equal to external force in the opposite direction. So stress is internal reaction given by body per unit area of the body. Now, different types of stresses. First one is direct stress, is due to direct load. Look on the board. This is a body. And force acting along the axis of the body, and this is shaded area on which force is acting. This is tensile force, and take another body. This is compressive force acting on this shaded area. So here area is perpendicular to the direction of force, and direct stresses are classified as compressive as well as tensile stress. Second one is shear stress. Shear stress is induced due to shear force. As we already studied shear force, when tangential forces are applied on the body, what will happen? It will get shear off. Upper layer will move forward and lower layer will move backward. So this is shaded area is called as shearing area due to shear force. Here shearing area is parallel to the direction of shear force. Area parallel to force. Consider an example. Two plates are joined by bolt. This is a bolt which joins two plates, and two forces, that is shear forces, are applied on the plate. What will happen? Bolt will get shear off. Look into another diagram. Upper part of the bolt will move with plate 1 and lower part of the bolt will move with plate 2. This is shearing area of the bolt, which is parallel to the direction of force. Now we are going to see strain. Strain is ratio of change in dimension of the body to the original dimension. So there are different types of strain. First one is longitudinal or linear strain. this is body, and forces, that is direct load is acting on the body. What will happen? As these are tangential forces, body will get elongate. These are the dimensions of the body. This is length, width and height of the body. So due to tensile force, body will get elongate, that is changes in their dimensions. L2, W2 and H2 are the dimensions of the final deformed body. So linear strain is strain along the direction of applied force. Here in this diagram we will see that length is parallel to the direction of force. That's why linear strain is change in length per unit original length, that is L2 minus L1 upon L1. Now lateral strain along the direction, that is lateral or perpendicular direction to the direction of force. W and H are perpendicular to the direction of force. These are the dimensions which are perpendicular to the direction of force. So lateral strain is change in lateral dimension per unit original lateral dimension. So lateral dimension will be width or height. See, lateral strain is equal to change in width per unit original width, that is W2 minus W1 upon W1, or change in height per unit original height of the body, that is H2 minus H1 upon H1. Third one is shear strain. This strain is due to shear force, that is tangential force. So look into the diagram, these are tangential forces. What will happen? Due to tangential force, the body will get shear off. So this is triangle ABC and phi is shear strain. Here tan phi, which is nearly equal to phi, equal to BC upon AB, that is x upon AB. Here x is the change in dimension along the direction of force. Shear strain is equal to phi is equal to now volumetric strain. Volumetric strain is equal to ratio of change in volume to the original volume. let us consider a body. When forces applied on the body will get deformed. Here tensile forces are applied, that's why body will get elongate. These are the dimensions of the body. L1, W1 and H1 are the length, width and height of the body before application of the load, and in the second body L2, W2 and H2 are the dimensions, that is length, width and height of the body. V1, that is volume of the body, is L1, W1, H1, and V2, that is volume of second body, that is L2, W2 and H2. So change in volume will be W2 minus V2 minus V1, that is delta V. So change in volume per unit original volume is equal to delta V upon V1, that is L1 W1 H1 minus L2 W2 H2 upon L1 W1 H1.